Okay, I'm back now, and this here is one of my wind-powered generators. I know it's huge, it's bulky, but again, you guys can use your imagination and break it down. What I've done here is for the center, where all my cores and everything are going to be, I've laminated 3 layers of 3/4 inch plywood together, and what I did was I just cut them out of what plywood I had, and it worked out that I had a bunch of squares almost 2 foot by 2 foot. So I rounded them off, sanded them down a little bit, laminated them together, and then for the shaft, we have a local place out here called Princess Auto. You may have it down your way. You may find another TSC or any type of hardware store. And I picked up a nice set of bearings along with a shaft, and it's a keyed shaft, and it works great. You know, very little effort to spin it, and well, I kind of got lazy. I haven't got the any propellers or anything on it, so I just tapped on a little socket on the end of it there, and attach it to my drill and just go at a slow speed, and it's been quite successful. I figure probably around 200 RPMs. I'm putting out right now about between 48 and 49 volts out of it. Now, right now it is set up as just a single phase. I've got all my coils all running in a series, and the reason for this video is what I'm going to be doing is I'm going to be disassembling it, so I thought I'd just show you how it's been put together so far. And I want to make all my coils and convert them over so I've got a 3-phase. Now with a 3-phase, your voltage may drop a little bit depending on the amount of windings, if you want to add more windings to it, which is fine. But your current will go up. So anyway, stay tuned here, and I'll break out the wrenches and screwdrivers, and we'll start disassembling it here, and I'll show you exactly how I put it together and how I've made my windings. Alright, stay tuned. Okay, well, we've got it all apart, and these are my coils, as you can see down inside here, and right now I have them all running in series. Okay, so they all come around, come back in, and what I've done is I've done terminal strips, and I've done just a basic bridge rectifier. You can go on and Google that, and it'll show you exactly how it's done. The wiring over to it, over here I did a little timer circuit with a pickup coil that I've assembled. I was gonna see if I could possibly make it self-propelled, so you know I don't need to have wind or anything else. I'm still working on it. I haven't had any success with it yet. I've followed some of the directions and plans from other websites, other users. Again, I haven't had any success, but it could be probably just the location of this one particular coil that I'm using for a pickup. So now what I'm working on is if I can work on a reed relay rather than working with the pickup coil for sending the pulses to the timer to drive a few of these coils, and that way I can adjust it according to the way the magnets, as the magnets come through for timing. Now again, as I told you, the core is a 3-layer 3/4 inch plywood. So what I did was for the rotor, with the magnets in it, I did the same thing, and I cut an exact circle out of the center of it. So you get your 2 foot, you draw your lines crosswise, and you'll find the center point, so you know exactly where your shaft is going to go. And then you cut this out and then shave it down so that it will have just enough clearance just to pass your coils. Okay. Right now I have a little bit extra clearance because what I wanted to do was I just wanted to use zip ties here just to temporarily try it to see how it works. But I don't have the magnets close enough to the coils yet to where I want them to generate the most magnetism in the coil. So what I've done is I've left that little bit of an extra space, and with these magnets here I've got enough room to snap one more magnet onto it to add an extra magnet. That'll give me a little bit extra power off of it and closer to the coils. Okay, now what I've used is I've used the 1-inch round neodymium magnets. Let me see if I can grab some here. They're sticking to everything as usual. Screws, drills, everything. So these are the, oh, there's a washer that's stuck to it too now. It won't come off. They're extremely powerful. So anyway, all right, let's see if we can. Yeah, you got to have strong fingers to work with these. So that's my 1-inch neodymium rare earth magnet. And what I've done is I've arranged all these so that the north on every one of them is facing out. Okay, the south is always inside. The north, they claim, is the stronger side of the neodymium magnet. Now, when you buy these, they don't have north and south marked on them, so you don't know which is which. But in your location, if you know what direction north is from your house, what you can simply do is stick a few of them together and put a string in the center of them and just hang them. And as they spin around, it'll take maybe a minute or so for them to stop, but they will stop, and the north side of the magnet will be facing north, believe it or not. It's just like working a compass. So, whoop, and they're all stuck together again. Anyway, okay, so what I've done is, as you can see, I've got a base plate here, and that's where I've mounted my bearings to, and you can see inside where the one set of bearings is still mounted to it. Then I have my 3-core for my rotor and my coils. Okay, and then my rotor. And then over here, amongst the rest of the junk pile, I have my top side, or my other side of my my plate with my bearings mounted in it. It's very simple. It's easy. As I say, like you can carefully mark out a circle, and then cut it out with a jigsaw. And once you've cut it out with a jigsaw, mine, I've got just a hair over 13 inches. 13 1/4 inches roughly through the center of it. It's not an absolute crucial point. Just as long as you're around between 12 and 13 inches, that should be more than sufficient enough for you. And then what I've done is this one here, I've actually put a bunch of screws in it. You can see all my markings where I've lined it up so it's all equal. Okay, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 magnets on this one. So I've laid it out for 16, so that means if I have 16 magnets, I have 16 coils. And what I'm planning on doing is I'm trying to make I'm going to see if I can rewire this to make a 3-phase generator, which in theory only uses 15 magnets and 15 coils. Okay, because you got to go in multiples of 3. So that would be 3 sets of 5 all the way around. That would leave me 1 extra magnet and 1 extra coil. Well, the 1 extra magnet and the 1 extra coil, I'm going to turn around and either I can use that as the driver coil, so later on if I decide I want to try to see if I can get the pulsing going again in it, to get it to self-propel, or I can use it as a timing circuit for a small tachometer, so I know how much RPM the rotor is spinning at. I just had a buddy of mine here, and he turned around and told me that this unit seems like it's pretty big. It's too big to be putting up onto a tower for a wind generator. But he says, because I have a uncut long shaft on this unit right now, he says that there would be fantastic if you were to set up a small water wheel and make some sort of a housing or a casing on this that would make it waterproof. Well, just so happens I'm lucky. I have a small little creek that never dries up in the summertime in the backyard, and it's always flowing, so I'm going to try it. It's one thing of being an experimenter, you know. You gotta try different things. You can't just go by somebody else's set of plans. You gotta use that as a base starter and then work on your own design and your own set of plans. Now what I've done is, in order to join all this together, I've used 3/8 threaded rods. I've cut them into 12-inch lengths. You know, I put a nut and a washer on one side so it doesn't pull through. And then in between, I measured it all out, because later on, if I find that this is working good, then maybe I'll cut another rotor and coil section and put another one inside. So that way what I've done is I've used spacers, and I've just cut chunks of steel electrical pipe, or EMT, to the lengths, and just use them as spacers, and then I put the other board on top of it and join them together. So later on, if I decide I want to put another coil pack and another rotor with magnets, then I can just shorten them down, and I've still got space to do that with. You know, once you get the taste of generating a little bit of power, then obviously you want a lot of power. So you never know. Like, this is just a base starter. It's an experimenter starter. Okay, now what I've done for the coils right now, let me get the spool out here so you can see it. And oh, still can't see it. There we go. 32 gauge enamel coated copper wire, or known as magnetic wire. Okay, and what I've done is, each one of these coils right now is 3,000 turns. Okay, now to do the turns, yes, you can get precise, and you can turn around and put a counter on it and count every one of them. And what I did was I counted the first one, and once I counted the first one, then I just turned around, took a measurement, and I marked it out, and I figured if all of them are pretty close, it's not going to matter too much. Okay. Now, for winding them, what I've done is I've used a piece of 3/4 inch PVC plumbing pipe. Okay, now it's 3/4 inch on the inside, but it's exactly 1 inch on the outside. 1 inch magnets, 1 inch center core. Okay, and the center core, what I've done so far is, let me see if I can find one here. Okay, this one here is a larger one that I've designed. Normally mine are only half the size, which is what I've done is I've cut 1/2 inch pieces off of the 3/4 inch pipe. Okay, and then using a hole saw, I had some 1/4 inch plywood. So I cut a couple of pieces of 1/4 inch plywood. Okay, and again, here's my 3/8 threaded rod, my nuts, my little handle to turn everything. Okay, and what I did was I had a 1/2 inch nut, and I just rounded the edges of it off. And by doing so, this little 3/4 inch pipe fits real nice and tight onto it. Okay, there, and it's on. And then once I got that on there, then I turn around and I put my other piece of 1/4 inch plywood on, and then I put a nice little nut on it to tighten it up, which works out perfect. Now, as you can see, I have little slots that I've cut inside the 1/4 inch plywood, and what that's done for is I'll run a piece of enamel wire through it so it's touching here, and I'll run another one over here on the other side so it's touching through also. And I'll show you in just a second why I've ran a piece of wire like 6 or 7 inches long and just put it in there. Okay, and then when I start my wire, I use this third little slot here on the outside piece. Oh, my heater just kicked in. And I'll leave 3 or 4 inches extra outside, and I'll use that to hold my wire as I start to spin it. Okay, now as I finish spinning my 3,000 turns, my last little piece, I'll bring it through here, spin the wires together just to hold them together temporarily. And in this process, what I use, I know everybody can find these big pails. I can't find a pail of 2-part epoxy. So it's me and the Gorilla. It's an epoxy. I break it open, it mixes itself. There's no mixing involved with it. And what I'll do is I'll just squirt a little bit to start it, and then it comes with a wooden mixing stick. So, I'll do a couple of rounds and just smooth it out with the wooden mixing stick. And as you crank the wire, okay, that epoxy keeps floating up to the top, so every wire is constantly getting an even coat of epoxy, which will harden and join itself together. Now once you've done your 3,000 turns, like I say, the 3,000 turns is just a base starter. Okay, if you want to go 6,000 turns, you can go 6,000 turns. The more turns, the more voltage. Okay, and what I'm going to do is, I had somewhere here, probably buried up underneath everything else, big garbage pile. But anyway, okay, this is one of my other coils that I've done. It's a little bit heavier gauge. It's a 22 gauge wire that I've used here. But those starter wires that I was telling you about, that you leave 6 or 7 inches long, okay, it's easy. Once you've finished wrapping, then you can turn around and twist these together before taking them out of the housing. Okay, that holds the wire secure, and then when you're taking it out of the housing, everything comes out with it at the same time. And it holds it together until the epoxy dries. Okay, I found that Some people have said, like you can see, I've done a little bit of a wax coating on them. They say, oh, it doesn't stick or whatever. Yes, that's true. It won't stick with a little wax, like a candle wax or whatever, if you coat the edges of this. But what I found was if you're not fast enough and you allow the epoxy to harden, not all the wax will coat the outside of the housing, and some of the epoxy will actually stick in there. And it's very tedious to try to go along with a little knife on a slight angle to try to loosen up your coil with the risk of scratching the enamel off of it, shorting it out, or even cutting one of the wires. So this way here, just as soon as you finish winding it, you use these two wires, you know, you kind of wiggle it off and pull it out, and it'll come out. Here, there's one that I've done. Okay, and it'll come out with the little piece of PVC piping that you've had in there. There's no need to worry about removing that PVC piping. You can use it for mounting the coil once the coil's hardened. You know, if you can find a stainless steel washer and maybe a stainless steel bolt. So you put the stainless steel fender washer on the plastic and then a bolt down through it. And the reason I'm saying stainless steel is because stainless steel has no magnetism, so it won't stick to your magnets and create eddy currents and stuff like that. But like I say, for now, it's all experimental. Okay, like I said, I've done my 3,000 turns with the half-inch PVC piping on it, which is a perfect spacing. It gives you your 1 inch for your outside diameter of your magnets. And if we can pull one of these magnets off, you'll see it's a perfect fit. Okay, so again, you know, I'm just giving you guys a little bit of an insight on what I've done and how I've done it so far. It seems to work as a generator. Again, you know, like I've tried to do it as a self-propulsion or generating system, but I haven't had any success with it, but I'm not giving up. Okay, I got to keep going at it. I'll find the secret on it somehow, and once I do, if I have any success with it, I'll post any more of my findings up here on the internet. Anyway, I've been going on now for about 24-25 minutes, something like that. I know I've been known as a little bit of a windbag, but like I say, I'm just showing you guys what I've done, what success I've had with it so far, and it keeps me going. You know, like you guys use your imagination, you figure out exactly how you want to do it. This is the way I've done it so far, and I've had success, and I can't see anybody else having any failure. Like this here is just rough. I only did it in a weekend, and you know, I just wanted to see the basis of it, see if I could get it to work myself. And I know you got to surf through the internet and find out what's BS and what's not BS. Well, you know what? So far, what I've done here, there's no BS to it. I'll put up another posting up once I turn around and see if I can make this into a 3-phase, and I'll have meters on it and everything else, and I'll show you my success. If I didn't succeed, it's a failure, you know. But that's the downside of experimenting. You got to try it, and if you're afraid to try it, you'll never succeed to begin with. So, anyway, ta-ta for now. We'll talk to you all later. Have a great day. Enjoy your weekends, your weekdays, and we'll be back soon. Thank you.